Here's a short review on a few different things that have come up in chapter 4 that people struggle with. First, we're going to start off with the difference between ionic and covalent. Ionic bonds are a metal followed by a nonmetal. So I like to think of this as your typical couple walking down the street. You have your metal, your nonmetal holding hands, and that's ionic. Whereas covalent will be between a metal, that's a nonmetal, and a nonmetal. So that's just two best friends hanging out. We're going to look a little more at ionic right now because those are a little bit trickier. If we go into ionic, let's say we have magnesium, which has a 2 plus charge, and chlorine, which has a -1 charge. I know magnesium is a metal because it comes at this part of the periodic table. Everything with a plus charge that's in this area of the periodic table is a metal. And I know chlorine is a non-metal because it has a negative charge and it's above this staircase. It's not actually a staircase, it just looks like one. And those are all non-metals over here. So back looking at this, if we were combining our magnesium and our chlorine, we know those are going to go and make magnesium chloride. But when we're doing that, we need to know how many molecules or how many atoms of chlorine there are and how many atoms of magnesium there are. How we can tell, and I'm going to show this first visually for all you visual people out there. Let's say I took this magnesium and tossed it into a container full of chlorine. So here's my magnesium just sitting plus two charge. Now, its whole goal in life is to get a neutral charge. So just no positive or negative. That's the goal of every atom out there. So to do that, it needs to pick up a chlorine. So now we have one negative charge, two positive charges. Still not quite neutral, so he's going to pick up one more chlorine. And there we go. We have in total two negative charges, two positive charges. So that's going to make a neutral charge. And that's the end game goal. Now, if you look at this, we have one magnesium and two chlorine. So we can write this as magnesium chloride with a 2 there to show that we have one magnesium, two chlorine. Now, to finish off this equation, let's balance it out. On this side, we have one magnesium. On this side, we have one magnesium, so that's good. On this side, we have two chlorine. On this side, we have one. So let's put two chlorine into that equation. And that would be all balanced and good to go. So give it a try with something else. Let's say manganese, so Mn. And let's go with oxygen. So with manganese, we look at a periodic table, and that's just right up here, number 25. And you'll notice that it has three different charges. We have a 2 plus, a 3 plus, and a 4 plus. For this example, I'm going to pick the 2 plus. So it says 2 plus. And most examples will say what they want. And I'll get into that in just 1 minute. And the oxygen here, number 8, has a 2 negative. You know what, let's do the magnesium 2 plus, and I'll do a second example with the magnesium, manganese, 3 plus. So these are both going to go, and if we look at this one, here's a shortcut. Instead of drawing out, you didn't see it the whole time, there we go. Instead of drawing out the magnesium getting dumped into a container full of chlorine, or in this case, the manganese being dumped in a container full of oxygen, you can go and just do it a little easier. You have a 2 up here, so go bring that down, and you have a 2 over here, bring that down. So our result would be manganese 2O2. But in this case, because they're both 2, we can reduce that and just say manganese oxide. Now in this example, we have a 3 here and a 2 here for the charges. We can bring our 3 charge across and our 2 charge across. And that's going to give us manganese with a 2 here and oxygen with a 3 here. So to balance that out, then we can look, we have 2 manganese on this side, so we need 2 on this side. And we've got 3 oxygen on this side, so we're going to need 3 over here. For naming these then, we have manganese oxide, and we know that these, or you'll notice that these are very different, but if I was just calling it manganese oxide, I'm not going to know if I pick the 2 charge or the 3 charge. So in this case, whenever there is the metal has more than 1 charge, and it'll normally be something in the middle here. So normally, if it's asking for a metal from the middle of the periodic table here, go and check in case there is more than 1 charge. We're going to use Roman numerals then. So for this one, we call it manganese. And we're going to put 3, Roman numeral for 3, because it was a positive 3 charge, oxide. And you'll notice I finished off the word, the oxygen. Instead of saying manganese 3 oxygen, it's oxide. That's just how we finish it off with chemistry when it's a simple one. If we have something a little more complex, let's say we had sulfate, and that's got a -1 charge, and we were mixing that with magnesium. So we're going to be mixing those together, and we're going to create magnesium sulfate. Now when I'm looking at that, first off, I need to go and bring, that was about the camera, the 2 from here and the 1 from here across. So I'm going to put brackets to show that the 2 applies to both those. I don't need to write the 1 if there's just 1. And from here, if we're writing the name for that, we're going to start with magnesium. And we can look at this and say that looks a lot more complicated. There is 3 different atoms here. We have a sulfur, we have an oxygen, we have magnesium. And that's when you start thinking it's not going to end with "ide," it's going to end with "ite" or "ate." And then just go and consult. Most of the time on your periodic table, on the back side, will be a list of common ions. And just consult that, and you'll see, in this case, sulfate. I think that's all for now. Hope you have a great day.